Bell, and I'm the director of Plant Chicago. Aquaponics is a combination of hydroponics and aquaculture. Aquaculture is fish farming. Hydroponics is growing plants in water. So when you put the two of them together, we're consuming the waste from the fish in a closed-loop system. So the only input to this system is fish food. The fish are fed. Right now, commercial fish food will be transitioning to our own homegrown fish food. Some of it will be brewery waste, like spent barley. Some of it will be algae, duckweed, insects potentially, and probably red wigglers, worms. So in this system, the fish waste, the fish water, travels through a sedimentation filter first, which knocks the solids out, and it goes into a biofilter, where there are two different types of bacteria that convert the ammonia in the fish waste, fish urine, into nitrites and nitrates. That fluid, or that water that's now nitrate rich, goes to the opposite end of the growing bed and enters down there, runs underneath the plants. This is a raft system. In a raft system, the plants are floating on these foam rafts that let the roots dangle into the nutrient-rich water. From here, the water travels back to the pump reservoir, where it's heated to an appropriate temperature for tilapia. In this case, we keep it about 72 degrees. And from there to the fish tanks. And it starts the process again. So the fish waste goes into it, gets filtered out, turns into nitrites, feeds the plants, goes round and round and round. And the water is living. There's all kinds of microbes in here. It's much more like real water in the real world. It's not like the water in a fish tank or in a traditional hydroponic growing system. In hydroponics, you're using chemicals. You're adding nitrogen and phosphorus that are derived from petroleum, from all sorts of other places. In this case, it's entirely fish waste. At the plant, we're closing waste loops here, and the farm is one piece of the puzzle, and it's tied in with the brewery and with food manufacturing spaces and office space, so that waste heat from growing systems and waste oxygen from growing systems can be put to productive use. So for instance, there's a kombucha brewery in the building. The kombucha brewer needs oxygen and makes carbon dioxide. Plants are the reverse. So we can feed our waste oxygen to him, and he can feed his waste carbon dioxide here. Same thing for the brewery, the beer brewery. Carbon dioxide coming into the system, waste heat from here being used to heat offices, generally space heat the building. Once we build our anaerobic digester and combined heat and power system, the loops get much more intense and much more efficient. We'll be consuming all of our own waste, plus about probably 25 tons a day of food waste from neighboring businesses. All of the electricity for lighting our plants and other uses like blowers and cooling and other things in the building will be generated in the combined heat and power system, which is a recycled military fighter jet engine tied to phase synchronized generating equipment. Believe it or not, there's nothing new about anything we're doing here. It's the combination of many existing technologies in one facility that's new. And that's really the only new thing here. The military jet engine is being remanufactured by Elcor Energy Solutions in Arizona. They've been doing this for years and years and years. All of their installations are west of the Mississippi. This would be the first one east of the Mississippi. But again, it's just an engine burning gas. In this case, it'll be biogas. But it's the way it's combined within the plant systems that's the innovative portion. We're in front of production bed number 1 here. We're building 2 more identical beds down the line. These are still essentially research beds. We're calling them production beds because we're raising lots of produce, and the 3 of them together will produce enough greens to be worth selling. Very soon we're going to start prototyping vertical systems in the basement here, which will convert 1 square foot of floor space into 8 square feet of growing space. Once we start doing that, then the production levels are going to go way, way up. And we'll be filling eventually about 32,000 square feet of this building will be dedicated to the farm. Not all of it will be grow beds. Some of it will be areas with fish tanks or processing areas, packaging areas for the produce, equipment space. But 32,000 square feet devoted to the vertical farm. Initially, our produce is going to be sold at farmers markets and through restaurants, or to restaurants. Once the larger production numbers start coming in and we have more systems operating, then we'll be targeting wholesale market. Probably customers potentially like Testa Produce, who are 3 blocks away from us. They're a sustainability-focused distributor with a new LEED Platinum facility just next door. And so we're hoping that we'll be able to work a deal with them to sell our produce through their distribution chain. Plant Chicago is an open source project, meaning all of the designs and the technologies that we're developing here are going to be freely available to anybody that wants to use them. So we're building a website with a very high level of documentation showing absolutely everything we're doing in the whole process, including software you can download to run the systems, including materials lists, suggestions about where to get recycled materials, who to look to for getting things donated, as much information as we can muster. We're trying to encourage other people to do similar things, to move food production back into cities, especially in derelict industrial buildings.